Okay, good morning, all of you. In today's session, the second session of lenses. So, we have had sessions on refraction, and last session we started lenses. So, in today's session of lenses, the topic is going to be what are the different properties of focal length. So, I'll just quickly remind you that in every lens there is an optical center. So the optical center is, well, virtually that is the center of the lens. So in every lens there is an optical center. From the optical center to the focus, that distance is called focal length. So we are going to just have a session today. What are the properties of focal length? So one thing I want to tell you, that never forget this, that in a lens there are two assumptions which I told you in the last session. First assumption is that the aperture is very small. Aperture means the end to end width, it is very small. And the second assumption is that the lens is thin, right? The thickness of the lens is negligible. So these are two very important assumptions. The aperture is small, lens is thin. Now, when we do lenses, we assume that the material is glass, obviously, and just outside the lens, it is all vacuum or it is all air. That is what we assume. Like the lens itself is glass, but everything outside the lens is vacuum or air. That is what we assume. And if we assume that, and if the lens is equiconvex or equiconcave, that means the radius of curvature is the same for either spherical surfaces, then the focal length on the left side and focal length on the right side will always be the same. So that means what? If the surrounding medium on left and right is the same, right? And if it is equiconvex or equiconcave, that means if the radius of the spherical surface on the right side and the radius of the spherical surface on the left side, if they both are same, then the focal length of the left side and focal length of the right side will also be same. So the focal length, like from O to F1, you can call it small f1, and from O to f2, you can call it small f2. So small f1 and small f2 both will be the same. Secondly, if you ever hear the word focus in a very general sense, like there is some discussion or some question somewhere, and you have just heard of the word focus. So whenever you hear the word focus, it means f2. Okay? Generally, if you hear the word focus, just if you hear the word focus, that means that we are speaking about f2. So I just want to quickly remind you what exactly is f2. So f2 is basically, in case of a convex lens, it is the ray parallel to the principal axis is coming to f2, and in case of concave lens, the ray parallel to principal axis appears to be going out of f2, right? So if you ever hear somebody say focus, just focus, like they're not saying f1, they're not saying f2, they're not saying all that, they're just saying focus, then focus generally means f2. So in case of convex lens, it is on the right hand side, and in case of concave lens, it is on the left hand side, because the definition of f2 is that ray parallel to principal axis in case of convex lens actually meets at f2, and in case of concave lens it appears to be coming out of f2. Now this actually meets, we say it's a real focus, and it appears to be coming out, we say it's a virtual focus. So real focus means that the ray actually goes there, and virtual focus means the ray appears to be going from there. So convex lens has real focus and concave lens has virtual focus. Number 4, I had told you that ray parallel to principal axis will meet at f2 or appear to come from f2. But rays may not be parallel to the principal axis. They may be parallel to each other, but they may not be parallel to the principal axis. They are called oblique rays. So notice these two rays are parallel to each other, but they are not parallel to the principal axis. They are called oblique rays. And similarly here, these two are oblique rays. So instead of parallel to the principal axis, if you just have rays parallel to each other, they are called oblique rays, and oblique rays will not meet at f2 or not appear to come from f2, rather they will meet on a plane containing f2. That plane is called focal plane. So these two oblique rays will meet on this plane. So this is the focal plane, and similarly these two oblique rays will appear to be coming out of this plane. This is the focal plane. So focal plane is the plane passing through f2, and in case of oblique rays for convex lens, they actually meet over there, and in case of concave lens, they appear to be coming out of the focal plane. Okay, now when I was telling you that if the medium on both sides of the lens is the same, then f1 will be equal to f2, that's what I was telling you. So focal length depends on the surrounding medium. So if you place so that means focal length depends on the surrounding medium, because if the medium is the same, then f1 and f2 are equal. So if you place a lens in water, that instead of air, the focal length will increase. So focal length depends on the surrounding medium. If you place the lens in water instead of air, then the focal length will increase. So it depends on the surrounding medium. That is point number 5. Okay, point number 6. Focal length depends on radius of curvature. So if you have a thick lens, then the radius of curvature will be less. So focal length will be less. If you have a thin focal lens, the radius of curvature will be large, and the focal length will be large. So it depends on radius of curvature. This is point number 6. Okay, point number 7. If a part of the lens is covered, the focal length is unchanged. So if you cover a part of the lens, the focal length will be unchanged. So the amount of light will decrease. Okay. If you cover a part of the lens, then what will happen? The focal length will be unchanged. So the amount of light will decrease, due to which the position, size and nature of the image doesn't change, but the intensity will reduce. So this is a very famous question which often comes in the school exam, that if you cover a part of the lens, how will the image be altered? So the answer is that if you cover a part of the lens, then you are not allowing enough light to enter. So the intensity of the image will reduce, but the position, size and nature of the image will not reduce. So these are the 7 points. What is the properties of focal length? These are the 7 points. So next session we'll move into ray diagrams. Okay. Now today the homework is, you will have to write 3 points of comparison, any 3 points of comparison between concave lens and convex lens, any 3 points. Like, how is concave lens different from convex lens? You will have to write 3 points of comparison, or you can say 3 points of difference. So that will be your homework, and there is no session tomorrow. Tomorrow is a public holiday, so there is no session or homework session tomorrow. So you can submit your homework by 9 p.m. of Saturday, right? You have to show 3 points of comparison between concave lens and convex lens. That is your homework. So I'll end the session now. Bye all of you.